Hi, welcome to this race session in anticipation for an amazing event you're about to experience coming up this weekend. I'm James Hodge, I work for Splunk. We're partnered with McLaren as one of their major partners for a few years. We're here in the Technology Centre in Woking, where a lot of activity happens over the race weekend you're about to see. And I'm really privileged to be here with Dan Keyworth. Dan, why don't you introduce yourself?
Yeah, sure. So I'm Dan Keyworth. I'm the Director of Business Technology for McLaren Racing. So I'm responsible for all the technology that we deploy across our multitude of race series. So you'll know us best for Formula One, of course, but we're in IndyCar, we're in Formula E, we're in something called Extreme E under the banner of our electric racing series. And we're also in esports as well, which I think we'll probably dive into as well today.
We're definitely going to talk about esports. I think it's one of my favourite areas that's really upcoming. So if we think about what you're going to come up for this race weekend, I think the thing we've got to address first is it's 60 years of innovation at McLaren. What does that feel like for you, Dan, being here and going through that kind of 60-year mark for McLaren?
Yeah, it was a huge amount of legacy and heritage to carry. You know, we were celebrating our 60th anniversary this year since Bruce founded the team. I think the point around innovation is really important there because actually we've been developing technology over an entire course of those 60 years. You know, 40 years ago, we were the first team to put a single sensor on a single car and gauge some kind of insight from it. And lots of people are trying to do that today, whether that's in the IoT space or connected cars. So, you know, we were doing that 40 years ago, we just never called it that. And we've developed ourselves over the years to, you know, the pinnacle of motorsport. Formula One is probably the most technologically advanced sport on the planet. And it's incredibly data rich. That's kind of our lifeblood of the sport. And that's the kind of thing that surges us forward, right? We've got this history that we have to carry forward, but equally we've got kind of new records to break in the future as well.
And the pressure on race weekend is absolutely immense. I think we're going to go on to it in a second, but the whole resilience of your operations here is quite complicated. It's a complicated operation to go and actually get an F1 car out onto track, and IT are a critical provider in that effort.
Yeah, absolutely. You know, resilience is kind of part of the game, really. It's a reliability component when it comes to going racing. Lots of focus clearly on the cars, you know, getting two cars round the track on a weekend. We go through free practice, through qualification and race, so we've got to navigate through each of those sessions. But as you say, IT plays a critical role in that. We kind of call our trackside infrastructure the third car, and we'll probably talk a little bit about what that looks like. But that's how paramount IT is to a race weekend. It is it's the brain of the garage, but equally it's what gives us all the information to stream back to here in Woking, so that a much larger team inside mission control can make quick and fast decisions. So, you know, resilience is mega important, whether that's at the track itself so that we can get the cars out and we can go racing, but also making sure that all systems are up throughout the course of the weekend so the team here can provide maximum performance back to the track.
And there's something on the slide here. Obviously, preventing major incidents is a paramount, but I think the absorbed shocks and the transformation is something I'd just like to dig into. Being able to turn on a Formula One car, you actually have to have all the telemetry coming off it first before you can actually do anything. It's, you know, safety critical. And so how do you go about making sure that is available, you know, it's reliable so the Formula One car can go out on track?
Yeah, I guess I'll give you a bit of a rundown what it looks like running into the weekend. Yeah. So we turn up at the track and it's a completely empty shell, and we build out our home, which is our garage. We run something like 2 kilometres of cabling, and we set up an entire garage in quite a short space of time. And we do that at every single race, so it's a fresh office install every time. And then when the team arrive, it feels like the last place they were. So the previous garage might still be being packed down and the new one is already in place. So they kind of go from location A to location B, and it all feels quite seamless to transition. The cars turn up, the IT turns up, and then we get to something called radio check, which is the goal that everyone's targeting to be race ready. So that's all systems are online, all intercom is operating and functional, and that all of the on-car systems within the car are capable of providing us all the information back into the garage. So we go through a huge amount of checks and a huge amount of preparation so that we can get race ready. Before the car goes out, the engineers will put their thumbs up, the engine supplier will put their thumbs up, and IT have to put their thumbs up as well, because we're a key component in that whole checklist before we're actually allowed to send Lando or Oscar out onto track.
So I love that. So just thinking about IT being an absolutely critical part of the Formula One team. We all see the glitz and the glamour, the driver, the people on the paddock wall, but IT are definitely there giving their thumbs up to allow that car to go out. Talking about the car, someone told me a statistic, approximately 90-something% of the car that ends the season has changed from the beginning of the season. Your continual development. But exactly the same for you in the IT space. Someone told me a statistic about every time you're out at practice, it's a 60-minute session, the car arrives back to the garage and you basically put an RJ45 kind of cable into the car to download the data from it. And you're always trying to get that kind of time window it takes to download the data faster and faster and faster. We won't go into the actual number here, but that's part of your continual transformation and that performance for every little last second of improvement.
Yeah, absolutely. Well, it's a sport of incremental gains. So, the development of the car is very representative of how the rest of the business has to move in line with it in order for them to perform right at the top. So, if the car that wins the first race in the season, if they do zero development, they would actually come last at the last race of the season in Abu Dhabi. So that's the kind of the rate of innovation that's happening in the car space, but that reflects onto us as an IT team. We have to move at that same rhythm. We can't get caught out. We can't be the part of the cog that doesn't perform. So we're there always trying to make those small marginal gains and really trying to amp up our support towards the team.
God, the pressure of that must be immense for you. I think the next slide we have actually is another high pressure scenario. So this is a screenshot of mission control. So mission control, maybe you can help describe it. It's like a clean, stable environment in Woking where you have 32 race engineers throughout the weekend listening to all the communication, all the telemetry that's coming live from track, making decisions.
Yeah, well, as you say, when you look on TV, actually the garage doesn't look that hostile, but it's quite a warm and difficult location.
It's really noisy. The first time I went to an F1 race, I couldn't believe the noise. We couldn't be having this conversation when the cars leave the grid because it's just too noisy.
Yeah, exactly. Yeah, it's deafening there. So there's a lot going on. So making decisions in the field, as I would call it, is always challenging. So it's really important that the team back here are digesting all of what is going on at the track, so that they can actually inform the team that are at the track to then inform the driver to go and make whatever decision we plan to do next. So, like you say, it's quite a serene environment. It's very calm in here, but actually there's a lot going on the track. So it's really important to kind of create this calm environment so we can be more data driven. I think that's a really important point. Look at the data. Where do we need to make those improvements? Whether that's in the setup of the car through practice, whether that's how we're going to extract more performance in qualification, or then when we're up against our competitors in the race, how we're going to get the edge on them, whether that's an overtake or whether that's how do our varying strategies play out. This room is split in two halves as well, so you've got Lando's team on one side and you've got Oscar's on the other. So that changes through the weekend as well. Very engineering focused at the start of the sessions, and then as we go towards quali and race, the strategy guys start to step in about how we're going to gameplay into the weekend.
And I think one of the first things I learned is how important resilience is for you. So data leaves the car, it hits the FIA then stream that to the garages, and where we hit the rig, which we'll come onto in a second, and then that gets streamed back here to Woking. So you've got 300 milliseconds from Australia, something like that.
That's right. Yeah. So 300 being the worst across the distance
basically
of the world.
Speed of light becomes your.
Yeah, exactly. Yeah. But yeah, it's having a guaranteed connection from those locations is really important for us, and having both those locations operational at any one time is what's going to give us maximum performance. Resilience is mega key for us.
And that's the first thing we kind of focused on when you and I started working together 3 years ago.
Right.
Was how does Splunk kind of help the digital resilience of that transport of the data, making sure that systems are up, they're available, so the engineers are able to go and do their job.
Yeah, it's almost getting that kind of pulse point of health across the business. And Formula One is an incredibly shiny sport, but actually it's very translatable into other industries, right? Where you want to get that single view of everything that's going across your organisation and what its bill of health looks like, and where do you need to go and respond and react? Go and chase the reds and the ambers, as I like to call it. But yeah, when we started working together 3 years ago, our objective was to get that single pane of glass across everything we do, track to factory, so that we can be 100% resilient all the time.
And I think the first thing I got introduced to, I think it was Circuit of the Americas. I flew out to meet you and some of your colleagues. You brought me into the garage and you said, let's introduce you to the third car. I was like, there are only 2 cars on the track. You don't have a spare car. And that's where you introduced me to the IT rig here, which you effectively known or affectionately known as the third car.
Yeah. It's gained that name because the third car in the sport itself doesn't exist anymore. So, what is more important behind the scenes than your third car is IT. So it's, over time it's inherited that term. But this is, as I said earlier, this is the brain of our garage. This is where everything comes to and is processed. If we talk about telemetry on the car, all the telemetry, as you say, gets streamed into each of the garages. We process that inside the trackside rig. We do lots of stuff within our application stack, but at the same time, we surface all of that telemetry data in a very raw format to the engineers. Both drivers have 2 engineers as well. You have a performance engineer, and then you have your chief engineer on each side of the garage. So your performance engineer is looking at all that data to go, is that performance of the car, is that driving style? What do we need to be communicating back to the driver to get a little bit more out of the car? So, this serves as the lights in the garage. Without this, the cars can't go out, particularly for safety reasons. But without what goes on inside the third car, we don't go racing. So it's
and it's a really hostile environment as well, because you've got heat, Abu Dhabi, Bahrain, those areas, you're like 40 degrees plus kind of garage temperature. The internal temperature of that must be astronomical. Plus you have carbon fiber dust, which for electrical components is pretty much the worst thing you could ever get.
It's not the traditional place you put a data center. It's well and truly at the edge. And as you say, hostile environments. So managing temperatures and managing those different environments round the clock is really important. Some races as well, it'll be cooler during free practice, and then suddenly gets really hot during quali and race. So we've got to make sure that the health of the kit remains stable. But equally, that translates back to the car and how that's performing as well.
And you even had the aerodynamics team come and create custom ducts, didn't you, for the rig to get the maximum airflow going through it?
Yeah, we did some CFD, computational fluid dynamics, which is a bit of a mouthful. We did that on the airflow of the trackside rig, so we could optimise cooling for all of those locations we go to. Particularly Abu Dhabi was the one we wanted to get it right at.
It's probably one of the most loved IT rigs in the world.
Yeah. That's great.
So I think we're going to kind of change pace a bit and go on to kind of just a bit more into detail on what happens. I think one of the things we have is, the car itself, 300 sensors in kind of at the beginning of free practice 1, 2, and then you drop it down to about 120-ish sensors for the rest of the time. If I get that right.
You remember your stats. You're doing well.
Yeah.
So 300 sensors at the beginning of the weekend. About 100,000 parameters of telemetry that's coming off the car at any one time. So it's a huge amount of data. The 180 that get stripped off, they're there to make sure we get the car in the right window. So getting all the balance right and getting it set up before we go into Parc Fermé, where your spec is locked for the weekend. So that's kind of where life starts, right? The car is probably the most advanced edge device you've ever seen, going at 300 kilometers per hour and streaming that volume of telemetry back. It comes into the garage, like I said earlier, and we process that with inside the trackside rig.
And that, just to kind of clarify, is you get some of it streamed in real time.
Yes.
Basically over RF. There's a fiber optic ring around the racetrack, streams it to the FIA, but you're obviously going to get gaps in that data because RF's not perfect.
Yeah.
So you'll also, when the car comes to the garage, then do a complete download to plug in all the gaps of your data as well.
Yeah, so we get 2 meg connectivity around the circuit, and when the car comes in, we have an umbilical cord, as we call it.
Yeah.
We plug in the car, and we get a full history from the ECU that comes off. And then we can plug some of those gaps, but also use that as kind of the gold source of data now that it's come off the car post session.
So it hits the garage, then obviously it's streamed back. And I think the interesting part here is the difference between kind of cloud technology on-prem and kind of, it'd be really interesting your mix of that.
Yeah, so we call the MTC here the core for the right reasons, where our main data center is. We we can only take a certain amount to the track. We are limited by weight and freight. So there's only a certain amount of capacity that we have at the edge, but we can do a lot at the edge. And then we have a lot more what I call grunt in the core. So we do a lot of high performance computing, particularly around simulating what the different outcomes of the race might be. So we do about 300 million simulations ahead of a race weekend. That gives us any indication and any outcome. If Lando's in sixth place and the safety car comes out on lap 7, there'll be some kind of indication of what strategy we may want to play, indicators to what that might be. And so it's important to kind of game out your race before it actually happens. We have a huge amount of storage here as well. So, we're storing data live from the race weekend, competitive onboards. We want to see what our competitors are doing around us as well. But also, this is where our back of house is. You see on TV the race element, but actually we design a car, we build it, and then we go racing. So the design and build element is a huge part of the operation back here in Woking. So we have a huge amount of compute and storage demands for that specific part, and that's before it's even got to the track. So we do a lot here. But equally, we leverage the cloud. We're kind of in a multi-cloud context here. For multiple reasons, really. One, where we want to do some R&D, so it's unpredictable burst capacity that we want to use. On a race weekend, let's say the weather's not quite right and it's raining, we may need a bit more compute, and therefore we would burst into the cloud to do a bit more simulation, because there's going to be so many more outcomes, and you've seen a wet weather race. It's incredibly unpredictable, but also very good for some of the other teams that aren't always there at the top. So we use the cloud, a lot. So we're definitely in this hybrid state. We've got to make sure we've got good resilience across both of those, because they're equally as important as each other to run not only the operation at the track, but equally the ones back here in the factory as well.
That's amazing. Quite, I think, a complicated infrastructure and operations that you're running here across like 20-something race weekends a year. You've got continual development, you've got the pressure of a race weekend, all the carbon fibre, the hostile environment, you have the unpredictability. It's some complexity there.
Yeah, the slide almost makes it look quite simple, but it's not.
Always, architectures make everything
of course.
It's proven. So Formula One isn't the only thing that's here. And I think we're kind of move on to a really kind of growing industry. I think also we're seeing for the younger drivers like Lando kind of grew up in the gaming era. And so he's a prolific gamer. You quite often see him streaming kind of live races. It's been a complete shift. So maybe, esports would be great to give a quick introduction to people about what it is.
Yeah, well, esports we consider it the 5th series that we do. It's an incredibly competitive space. And it's an interesting proposition as well, because the tradition of racing is you're a karter, you then go into the earlier formulas, and then you break into Formula One. But you need quite a lot of sponsorship behind you or personal funding in order to get there. So esports has really opened up the audience of who can go racing, which is really exciting. And we've run some competitions in the past.
The world's fastest gamer.
The fastest gamer, which was a really, somebody that had originally been a karter, but stopped racing, and then they went and won world's fastest gamer, and now they do single-seater racing because they're clearly good enough. So it's a really interesting proposition, because you've kind of got this parallel virtual world that is happening all the time, and there is a potential entry point back into the physical world, which we've already seen before. But the team here, our Shadow team, and Shadow being the kind of reflection of the real world, so that's where the name originates from, are a proper race team. So we've got 3 guys that race in a competitive series. We won the World Championship in esports last year, which is a huge step, not only for us, but also for the sport, to kind of show that it's a new style of competition.
And Lucas, wasn't it?
Lucas.
There's been some great YouTube videos of Lucas actually racing in real life Lando and holding his own, actually beating him a few times in karting.
So
these are not kind of don't think of these as gamers. These are professional drivers. The practice, the everything you look about it is as a professional racing team rather than something on the side. It is just as much as part of the McLaren family as anything else.
Yeah, I think you start with a rig in your bedroom, but then the complexity of the rigs grows over time as you become more competitive. These guys are real drivers. They're athletes. We treat them exactly the same. So yeah, I'm not surprised they can give some of our drivers and development drivers a run for their money.
And one of the things that you and I started talking about when we started this relationship, esports was becoming really big, and actually esports has a huge technology side to it. So you've got the infrastructure that runs esports itself, but I think a lot of people won't realise that the game, so like the F1 game that you can just download on your PC, Xbox, PS5, actually outputs telemetry. So for the techies there, you can actually output a UDP stream up to 60 hertz with over 300 data points. I think it's even more than an F1 car. So you can know things like the inside, the outside, pressure on each tyre, and each tyre you can know all the different G-forces on, everything you could ever want to know about. And you don't have the problem of physics and kind of radio waves to get the telemetry. It just throws all of that data out.
It's the ideal world, really, because there's predictability in it, so you can get, as you said, a much richer set of data from the game. And we ingest that, and you can really get a very comprehensive view of what's going on during the race. And we've built
some of these dashboards.
Some of the dashboards we built, yeah. So this is some of the Splunk competitive dashboarding that we've built. We use this as our core telemetry system in esports. Yeah. So our Splunk dashboard is our go-to source of surfacing telemetry and what it's telling us. And again, it's very similar to Formula One. You'll have engineers alongside our esports drivers coaching them on how they're going to perform better and get better through all the sessions. So it's a very similar parallel to F1.
I think we've got a great example of that. So you brought George Simmons. So George was part of the Formula One race engineering team.
That's right.
And someone went up to say, George, I've got a development opportunity for you. Come and have a go in gaming. I think George was a bit puzzled to begin with. And actually what George brought across to the esports team was a real engineering philosophy. And this, I think, is Zandvoort, where I think Lucas ended up winning. I think, as you can see, part way, the rain was starting to come in. They were doing okay, but George was able to see this, and by practicing the different scenarios, knew when to come in early for a tyre change, and you're actually bringing true race strategy into this, because they had been practicing using data. What was the optimum time to come in, depending on different weather scenarios? So it allowed George to make a snap decision during that virtual race and go and do that. And we can see kind of the win up there. I think that was a 1-2, I think we can see. So this is what we're seeing here is the race trace on positions. I mean, Dan, feel free to elaborate.
Yeah, so this is kind of the direction of the race, and you can see each individual driver and where they are. They're what we call their deltas between each other. So, you kind of see these instant drop-offs when an event happens in the race. That could be,
like here.
Yeah, and those are typically pit stops, or if there's a safety car, everyone drops at exactly the same time, which is probably this middle one here. So, yeah, it's a really interesting way to kind of see how a race plays out. And strategists will always look at this post-race as well to say, where could we have come in a little bit earlier and maybe done something different on the strategy. But it's a good example of where you take F1 know-how and you play that back into esports, and that it can have positive outcomes as well. So it just shows you how close each of the sports are. Again, why we call it a fifth series.
Exactly, and the professional drivers, with professional race engineers, all of the data telemetry you would get in Formula One. Actually, they probably have more data in some regards, and that's why you end up winning the World Series. Last year. And
I was there in one of the races, and we had almost felt like an F1 race weekend with all the engineers on a bank of desks, and just the conversations that were happening and how it was playing out. I almost forgot that we were doing esports. It was a really really interesting thing to see. So yeah, great achievement for the team.
I've still got a long way to go before I can I think challenge any of these guys in my rig from my office. I think here's George. That kind of uses it. But one of the things that we see, I think we've kind of shown with Dan and I talking, is we're really looking at how we can help prevent major issues, but more importantly, an issue is always going to come along. There's always going to be some IT outage. I think you actually have in the past had times when an F1 car hasn't been able to go on track because the Wi-Fi's down or something like that. And so how you go and absorb those shocks. But much more importantly, it's about accelerating that transformation that McLaren is going through. Maybe if you could kind of give a final view on kind of what Splunk means for you in kind of the whole overall racing environment.
Yeah, it's certainly changed the game for us in terms of our visibility across everything. You're right, things happen in this world. There's no such thing as 100% uptime per se. So having that visibility of how can you react quicker, absorb those shocks, as we rightfully say, and how you respond to them as a business is a really important thing. I think F1 demonstrates that you can do that in an incredibly hostile environment where you've got to make rapid and quick decisions. So taking that model and translating it back into other sectors is certainly achievable. And the relationships has given us an ability to say, where are weak points in our infrastructure as well. I think that's been a catalyst for transformation, because that could be our Achilles heel. Therefore, we need to move forward before it becomes a problem. So taking that from when you need to react, you can react and you know how to react, but actually being a little bit more proactive and on the front foot about where in my stack do I need to transform in order to be a leading and cutting edge organisation.
Well, Dan, thank you so much for spending the time with me today. Hopefully this has been informative for you and kind of demystifying some of the behind-the-scenes technology that happens on the race weekend. At the race, you're going to have an amazing time. Please go. If you've got any questions, just look for someone dressed like Dan, the partnership team. Some of Dan's team are at most of the races. There's always a technologist there to go and answer any questions that you have. Hopefully, we've also made the case for playing computer games in your bedroom. It is just as much real racing as kind of Formula One. And if you've got children, then you're maybe finding the next best thing. So have an amazing race weekend, and thank you for being with us.